Now we are in lesson 4.2. It's the derivative of a function. First, I'm gonna explain how did they discover the formula, the definition of the derivative of a function, or also we say the gradient of a curve at a point, or also the slope, okay, gradient slope derivative. First, guys, if you look at the graph here, you can see that I have 2 points A and B. And the point A has an abscissa x and the y, we say f of x. Now, I move a distance h from the point A and I have a new point B. X of this point is x plus h and the y is f of x plus h. And now if I want to find the slope of this line, if I join A and B, it's a line, it's a secant. We know that. And the slope, we know that from grade 9, it's y2 minus y1 over x2 minus x1. So it's f of x plus h minus f of x over x plus h minus x. So it's going to be this expression. Okay, till here there is nothing really hard. Now, when I start to move A to let it reach B, as A is approaching to B, as A gonna become to the point B, the secant is not anymore secant, it will become a tangent at the point B. So when A approach to B, what does mean A is approaching to B? H gonna be 0 here. So when I'm approaching A to B, there's no more H here. H gonna is tending to be 0. Okay? What will happen to the gradient of the secant AB, or the slope of the secant AB will approach to the slope of the tangent at this point. This is how we deduce the formula of the slope or the derivative at a point on the graph. So when h is tending to 0, so when I will calculate the limit of this expression when h tends to 0, as I'm calculating the derivative of this function at this point. Also, we can write it f prime of x or dy over dx, derivative with respect to dx. Now we will do some, guys, application after this remark to understand more about that. So if f prime of x exists, what does it mean? We say f has a derivative at x, or also we say f is differentiable at x. So now I'm just giving you the language. F of x, if f of x is differentiable everywhere, if I want to prove that f of x is differentiable everywhere, if the derivative exists for all x in its domain of differential. Those are just some definition. Let's move to the example to understand how do we find the derivative of a function at a given point using the definition of the derivative. So we call it the definition of the derivative. So first example, let's find the gradient of the curve y equal x squared at the point minus 2, 4. First of all, we start by the definition. We know that it's limit of f of x plus h, but here x is given, it's minus 2. So it's limit of f of minus 2 plus h minus f of minus 2 over h when h tends to 0. You cannot start to replace now. I will replace, this is f of x. So I will replace x by minus 2 plus h minus f of minus 2 plus x by minus 2 will be minus 4 over h. Now I will develop that's an identity. It's a plus b squared. It's a squared minus 2ab plus b squared. And then I will subtract. If you replace here h by 0, you will have 0 over 0 undefined. So you know that I cannot do that. I need to try to simplify and then to replace. So I can see that I have in the numerator a common factor h. When I factorize it, I can simplify. And now I need to find the limit of h minus 4 when h tends to 0. So when I replace h by 0, my answer is minus 4. What can I deduce? That the derivative of the function at the point of abscissa minus 2 is minus 4. Or also I can say the slope of the tangent, if I draw the graph and I try to draw the tangent at the point minus 2, the slope m of the tangent gonna be minus 4. Let's do another example, guys. I need to find, now it's the question is inverse here. I need to find the point on the graph. It means I need to find x for which the slope is minus 1 over 4. It means that the limit of f of x plus h minus f of x over h when h tends to 0 is minus 1 over 4. I'll start first, guys, by calculating the limit. So I will replace x by x plus h. I will have 1 over x plus h minus 1 over x over h. What I need to do here in my numerator, so I need to do the same denominator. So here I'm doing the same denominator. I'll multiply this one by h and this one by x plus h. So this is my numerator. Divide by h, it means times the inverse. Now I will have limit of minus h over x plus h times 1 over h. We can simplify the h. And now I replace h by 0. And I got minus 1 over x squared. They said here find the points. It means I have more than 1 point. So this minus 1 over x squared is equal to what? It's equal to minus 1 over 4. So I will solve it equal to minus 1 over 4. It gives me x squared is equal to 4. So I have x2 or x minus 2. And then the 2 points are for x2 and x minus 2. To be able to find what is y of the point, I just replace here x by 2. So one is half and the other is minus half. I hope that I'm not going so fast, guys, but just it's just a calculation. Another example. So given f of x equal radical x, I need to find f prime of x at x equal to 9. If you can see in each exercise, I'm trying to change the way of asking the question, so you can understand all the ways of asking this question. When I say here f prime, it means the derivative. I didn't say the gradient or the slope. So also the definition of the derivative, limit of f of x plus h minus f of x over h when h tends to 0. So I will replace x by x plus h. It will be radical x plus h minus radical x over h. If you replace here h by 0, you will have radical x minus radical x. It's 0 over 0 undefined. So I need to think about doing times the conjugate. For every time you have a radical, you multiply up and down by its conjugate. So it will be a minus b, a plus b, and this method will help me to cancel out the radical. So it will gonna be a squared minus b squared. So it's radical x plus h squared is x plus h minus x. And then I can now simplify the h, and I will get, guys, here its limit of 1 over radical x plus h plus radical x. Now I can replace h by 0. It will be 1 over radical x plus radical x, 1 over 2 radical x. They said they need to find the derivative at x equal to 9. So by what I will replace x now? By 9, and it will be 1 over 2 radical 9. Radical 9 is 3, so it's 1 over 6. What does it mean? The derivative f prime of 9 is equal 1 over 6. Now, when I say differentiability, is it continuous? When I say is it differentiable? When I say the differentiable or differentiability, it means there is an existence of a tangent. I have a tangent, one tangent at this point. When I say continuity, it means the figure will continue. It's not here, it's discontinuity. So if any function is differentiable at a point C from the domain of definition, so if I can draw a tangent on this point, it means f is continuous. This is sure, because if you have any graph, once you can draw a tangent, it means that it's continuous. But if it's continuous, it doesn't mean that it is differentiable. Because sometimes if you have like this, for example, I cannot draw one tangent on this point, and the proof of that in this example. So if I give you the function f of x equal absolute value of x, what does mean absolute value of x? This one gives me two functions. We know that absolute value is a distance. And if inside is positive, the answer is exactly as the inside. So if x is positive, the answer is like the inside. But if inside is negative, the answer is this is the opposite of the inside. So absolute value of x for an x tend to 0 plus, it gives me x. X tend to 0 minus, it gives me minus x. So if I do the limit of this function at 0 plus and 0 minus, I will check if I'm going to have two different slope or the same slope. If you do the limit of this function at h tend to 0 plus, so f of x plus h minus f of x over h. So here I'm working in this part here, and we did the continuity before in the preceding chapters. So it's going to be x plus h minus x over h over h, so it's 1. But if I do it at 0 minus, so I'm here, so it will be minus x minus h minus x. So it's going to be also minus h over h, so it will cancel each other. The answer is minus 1. It means I don't have one tangent at this point. What does it mean? This function is not derivative at the point 0, but if you look at it, it's continuous. It's continuous, but it doesn't mean that it's derivative. So if it's derivative, I'm sure that it's continuous. The inverse step is not right. The last part in this lesson just is the recall from chapter 2, I think, guys. So what are the different form of equation of a line? I have y equal mx plus b. It's a slope intercept form, or so we say also it's a gradient intercept form. Ax plus b plus c is equal to 0. We say it's a general form. Y minus y of the point is equal m factor of x minus x of the point. We say it's slope intercept form or point slope form. So not slope intercept. How did I wrote that? It's point slope form or gradient. This is the point slope form or the point gradient form. And we know that if m is the slope of a tangent, what's gonna be the slope of the normal because it's perpendicular. So we know that the slope should be negative reciprocal. That's it, guys. It's very simple, very easy. Just try to watch it again and you will